press record. Lene is going to be joining us soon. She was supply teaching today. So I'm just going to ask, I'm going to put it into the chat one more time. This is a direct link to the Pear Deck that we're going to be using today. If somebody can just kind of monitor the chat as new people join, they won't be able to see that link. If you can just kind of copy and paste it, I would appreciate that. And then when Lene gets here, she can take that over. But I am going to start class now. So today we are focusing on patterning. This is the teaching and learning support staff if you are looking for putting names to faces. So Lene Bates and myself are the ones who are supporting intermediate math. You may see Michelle Lang and Hebron also kind of dip into intermediate math at different times throughout the year. And just a quick announcement. I'm sure most of you are already aware of this, but I do just want to bring attention to it as we move forward. The topic that we are talking about today is algebra, patterns, and relationship. The long-range plans for both grade 7 and grade 8 have been re-imaged. So your layout there that you can see has been re-imaged to take into account our new spring break that's in April. And everybody in the system, so that we can realign the system so that students who are transitioning between distance learning and face-to-face are not missing any topics, will be starting the topic that we're talking about today on March 15th. So everybody in the system, no matter where you're at, you are expected to begin to teach patterning on March 15th, which means between now and March 15th, there are 2 priority topics, depending on where you currently are, these are our non-negotiables, and we want to make sure that they are a priority, that students are being exposed to this learning before March 15th. So there's only a couple weeks before March 15th right now. So if you have not touched on one of these topics, you want to switch lanes on what you are working on right now and move into either proportional reasoning or multiplying and dividing fractions and giving them some attention before March 15th. There is a month, you can see that consolidation square there at the end. So pretty much the entire month of June has been left as a buffer zone. And there are, I think, 3 days after algebra there, just before April. So you have 3 days before April break and the whole month of June to go back and revisit some topics that maybe you feel your students could use a little bit more instruction on because you had to glaze over them in order to focus on the non-negotiables. So our menu today is we are going to be looking at visual growing patterns, and then we do have a new curriculum. So we want to see what it's saying is important for grade 7 and 8 for patterning. And then we're going to move into a couple resources that have been created for you to help you with this topic. So some things that we as teachers want to unlearn as we move into teaching students through a conceptual understanding lens instead of just getting the right answer in math is many of us may have been taught in this form of y equals mx plus b, which is a super valuable equation for students to know, but it actually doesn't enter at the curriculum until grade 9. So it's not our job to be teaching them that M is first difference and you want to go to term 0 and figure out what the first difference is, and B is the term 0 that you're looking at, or you might think M is slope and B is the y-intercept. These are all true, but not part of our curriculum. Our curriculum is more focused on developing the idea of equivalency in expressions, and not just using some sort of a procedure to figure out what the algebraic expression would be. We want them to understand why the algebraic expression is the way it is, so that when they hit grade 9 and it's more on using that algebraic expression to learn different topics and to take the math a little bit further, they have a really solid foundation in what that M stands for and what that B stands for. So we're unlearning this today. This is not how we are going to approach teaching grade 7 and 8 students how to go about getting an expression for a pattern. We instead want to develop their multiplicative thinking about linear growing patterns. And that's what we talked about in our last just-in-time session on proportional reasoning. And instead of using numbers and tables of values for the pattern, we're going to visually represent patterns in various ways. And then our big role is to make connections between the different representations that this algebraic expression can have. So we're going to jump right into it. We have a little minds on for you. This pattern comes to us from visualpatterns.org, and I do have a link in the slide deck later on. So look at the pattern here, and you should see some drawing tools, some colors up right now. I want you to use those drawing tools to just show me how you see this pattern growing. And if you're at all curious to see what some of your colleagues have used, come on over to my screen in the Google Meet, and you're able to take a look at what some of your colleagues have drawn. Okay, so we can see some similar patterns here. We see some people are seeing it growing out and up, and other people are seeing it growing on a diagonal. Okay, so let's use the way you saw it there and make a note. How many stars do you predict will be in the 10th term? So go back to your pear deck. So how many total stars would be in the 10th term? Okay, would somebody be willing to unmic? So I see some people have said 20, some people have said 21. Would somebody be willing to unmic and just share with us how you thought, how do you know what your answer is?
Hi. Sorry, I haven't done it yet, but I could see that it is 2 times. I've seen that it's always doubling, so I could just take the second term, multiply it by 10, and then just add the 1 for the red star.
Okay, thank you. Anybody else want to share the way they thought about it?
For a visual perspective, I noticed that in each term, you go up by 1 star. So the first star, there was 1 blue star going up and 1 blue star going across. Second term, there was two stars, blue stars going up, 2 stars going across. So it followed that same pattern. So if you continue that, the 10th term will have 10 blue stars going up, 10 blue stars going across, and then the red one, for a total of 21.
Excellent. So what you're seeing there and what you're hearing is algebraic reasoning that's happening. So if I would have given you a numerical pattern that was 3, 5, 7, the students might not have been able to see in the same way how it's growing in those directions and how that red star is not changing and is always staying the same. So you're already starting to develop this idea of algebraic reasoning as the students are making connections between the term number and the stars. And we've picked a number 10 that's close. So they don't need to draw it all out. They can visualize it pretty quick, but we're forcing them to sort of make those connections between the number of stars and the term number. So now I think, if I remember what my next slide was going to be, I'm going to pick a number that's far away So something, here we go, I'll just put it up there. So now we're looking at what would the 100th term look like? And I want you just to think about it for a moment and notice that I'm asking you, what would it look like? I'm not asking you how many stars are in it. And what this is doing is it's far enough away that students are having to think algebraically. Like it's, you could see a set of 10 stars, but for them to have to be starting to make connections between those arms and those blue stars and knowing that that red's always going to stay the same, they're thinking in general terms now without me saying what would the nth term look like, which is very abstract for students. They really struggle with that when you throw that in. But when I say 100th term, I'm thinking abstractly for a concrete purpose. So does anybody want to open mic and just give me an idea of what do they visualize the 100th term looking like?
A 100 stars vertically and 100 stars horizontally, and then a red star.
Amazing. So right there, you have already done some significant algebraic thinking that maybe would not have been accessible to students had I gone 3, 5, 7 and asked them to create a table of values and think about term 0 and think about first difference. So you're already being able to visualize that. So let's just take a look here. Just give me a second. I'm just moving around in my thing here. Okay, so some of you saw the pattern look like this. And this is the other beauty. Algebra is very open to different ways of seeing things. There's lots of expressions that are equivalent that don't look the same. And this is a great way to honor that that everybody has a different perspective on something. So here we are. Those of you who saw it like this, you might have said, I noticed that each arm was growing by 1 and that the number in each arm was the same as the term number. Since there are 2 arms, I know I multiply the term number by 2. I also noticed that there is always 1 red star, but that doesn't grow. It stays the same, so I add 1 to the total. So my thinking is 2n. Oh, did I skip a slide? Yeah, I did. My question was how many stars would be in any term, and I was looking for an algebraic expression there, but I've already now just given it away. My thinking is that it would be 2n plus 1. Now, some other people saw it looking like this, and you might have been thinking that I noticed that in the first term, I had 1 group of 2. In the second term, I had 2 groups of 2, and in the third term, I had 3 groups of 2. So I always have the term number times 2. And I also notice that there's always 1 red star, but that doesn't grow. It stays the same. So I add 1 to the total. So my thinking is 2n plus 1. So again, here's a visual pattern that allows students to very quickly be able to distinguish what the algebraic expression is. And then it leads us to a conversation around what are the blue stars representing and what are the red stars representing. And this is building up their understanding of a rate of change and a constant. And I can start to say, oh, yeah, that blue star is the multiplier or the rate of change. It's constantly changing by the same amount because we're only dealing with linear patterns in grade 7 and 8 when we're asking them to come up with an algebraic expression. And we're going to get to more of that later when we look at the curriculum. But we don't need to bring in quadratics here that involve exponents. That's grade 10, not even grade 9, unless the new grade 9 curriculum does something different. So we only have to focus on linear patterns, which makes it very easy for them to be able to see how it's growing and what is staying the same. And there's the link right there. The visualpatterns.org link. And it is a great resource. You do have to just make sure that the pattern that you're choosing is a linear pattern, but you can throw these up as your math talk in the morning as they're walking in, or first thing in the class. As they're walking in, you can have one of these up on the whiteboard, or if you're distance learning, as students are signing on to the Google Meet, you might have something like this up and just get them thinking about how do you see it growing? Well, and what do you think the 100th term would look like? You don't even have to go to the expression yet, and you can work your way up to that. Okay, here's another one for us to try out. So use 2 colors to show how you see this pattern growing. So we use 2 colors for the multiplier and the constant. Can you use 2 colors to show me how you see this pattern growing? And just ignore the yellow block right now. And again, if you're curious what some of your classmates are doing, come on back to the Google Meet window and you can see my screen is showing how some people are seeing it growing. Okay, excellent. So all of you have used two colors. It looks amazing. And I can see two different ways that people are seeing it growing. How many squares do you think would be in the 10th term? And you can just, how do I want you to share that? I don't want you to write it on the slide because that's going to be for something different. How about you just throw it in the chat? How many squares do you think would be in the 10th term? So again, we're picking a number that's close enough, but kind of a pain in the butt to draw out, but close enough that I can kind of visualize exactly what that 10th term would look like and use my algebraic reasoning, and I can see some numbers coming into the chat there now. So out of 17 of you, 5 were willing to take the risk. Good job. Okay, so 31 is the correct answer. And I want you now to think about what the 100th term would look like. So again, we're moving into that space of generalization. I want you to think about something that's kind of so far out there, you don't want to draw it, you're thinking about it in your head, and you're making connections now to try and figure out what would that 100th term look like. And then I'm just going to ask anybody who would like to take a risk to unmic and share with us what you visualize the 100th term looking like.
I guess I'd see a tower, 100 stacks high of whatever color I pick for the three. So three up 100 times, and then I would see one in the bottom to get to 301.
Awesome. So look at how quickly Brad was able to do that calculation. Like he's visualizing 100 groups of 3 plus that extra one that's on the bottom. Right away I know, oh, that's going to be 301. So that's amazing. In the yellow box now, I want you to write how many squares would be in any term. So now we're moving from that thinking about the generalization to connecting it to an algebraic expression. So how many squares would be in any term? And just write that in the yellow box. There is a text option too. You don't have to like draw it out. You could just click on the T and then you should be able to type it out. Excellent. So I see most of you have written 3n plus 1. So you're looking at how many groups of 3 would I have? I would have the term number groups of 3 plus I would add that extra 1. However, some people have seen it in a different way. They didn't see it right away in term 1 as a group of 3 and as a 1. They saw term 1 as a group of 4 and then adding 3 each time. So let's take a look at what that would look like. If I was seeing it and it looked like this instead, if I colored it in this way, and we did have some people in the room today see it like that. So what algebraic expression would connect to the way this student has seen the pattern growing? And go ahead and write that in the yellow box, or you can type it in the chat, whatever works best for you. Awesome. Okay, you're nailing this. So what I'm seeing in the Pear Deck is that a lot of you are looking at this and saying, okay, well, how many groups of 3 do I have for each term? It seems in term 1, I have 0 groups of 3. And I'm talking about the green groups of 3. It seems in term 2, I have 1 group of 3. And in term 3, I have 2 groups of 3. So I have 3 times n minus 1, where n is my term number. So I have n minus 1 groups of 3. So 3 bracket n minus 1. And then in every single term, I can see this 4. So I'm going to add 4 to that. And that is a great opportunity for you as a math teacher to stand back and have a conversation with your class and say, we have some students who say the answer is 3n plus 1, and we have some students who say the answer is 3 bracket n minus 1 plus 4. Are these the same expression? Does this mean the same thing? Are these both correct? And how can we tell if they're both correct? And chances are your students are going to think they are not correct. And this is a great opportunity for you to explore equivalency. And we're going to come back to that in a few slides at how you could have your students looking at this. Our go-to tends to be to get them to simplify algebraically. And simplify is not in the grade 7 and 8 curriculum. So it is not our job to teach them how to simplify an expression. It is okay if they want to leave it in this space right now of 3 bracket n minus 1 bracket plus 4. But we do want to teach them that these 2 expressions mean the exact same thing and represent the exact same linear relationship. And again, I'm going to get to that in a few slides. Okay, so we're going to come back to this, looking at this. Your job, if you remember, I said, is to be making connections for students between the different representations. And your job is to be having them really explore this idea of a multiplier and a constant. So I might now have my students create a table of values. What would the table of values look like for this particular pattern? And it would look something like what you see here. But I'm not going to leave it at that. My consolidation point for this lesson is going to be, what connections do you see between the visual pattern and the table of values? What do we see happening there? What is the same? And so I'm just going to open the mic. Does anybody see anything happening in the table of values that you also see happening in the pattern? So open mic there.
You can see that it's growing by 3 after term 2 onwards.
Excellent. And then you explicitly make that connection for students. Can you see that as I'm going up the table of values, it's increasing by 3 each time? And where do I see that in the visual pattern? I can see, oh, it's also increasing by 3 each time. And you can also do this with this previous one here. With this, you could have both these patterns up and show how you can see that 3 is increasing with each pattern. Now, I might say to my students, all right, because I want them to understand this is a linear relationship and what it means to be a linear relationship. So I might say to my students, all right, let's pretend these are square tiles or some sort of colored tiles. If I took each term and I stack those tiles on top of each other into a vertical column that looks something like this. So I can see in term 1, I've got 3 green squares and 1 orange square, which is exactly what the pattern is showing me. I can also see in term 2 that I have the same number of green squares and orange squares. What do I notice about the way these tiles line up? And now the conversation can lead to that if I were to draw a line connecting these columns, I would get a straight line. This is really important for their development, is making all of this visual and making those connections and then talking about, why would it be a straight line? Oh, because I'm going up by the same amount each time. If I all of a sudden went up by 4 instead of 3, that's not going to be a straight line anymore. So making that visual and you explicitly making those connections for students is what's important for them to develop their algebraic reasoning. And then we reach a point that looks like this, where we can start to talk about, where do you see that 3 increasing in the graph? Oh, I can see that the green is going up by 3 squares each time, or 3 numbers on the y-axis each time. And then I can start to connect that to the algebraic expression of the 3n+1 that we've come up with. And I can start introducing the term of multiplier. So where do I see the multiplier? Oh, I can see the difference between multiplier and constant. When I look at that graph, that constant is staying as many terms up as I want to go. That orange square is staying at the bottom and not getting any bigger. But look at the green squares. Look at how they're multiplying amongst themselves at a rate of 3 each time. And that's bringing their multiplicative thinking to this as well, that I'm seeing it's increasing by a unit of 3 each time. Really, really important developmental pieces that we're connecting into the algebra. And I hope you can start to see now how these pieces would be missed if all we taught them was create a table of values, figure out the first difference, go back to term 0, there's your algebraic expression. They're missing all of this developmental piece that's coming out of it. This is a really great tool that lends itself beautifully to patterning, and it's called diamond paper. And the way you would create it if you were in a face-to-face environment is you would just have them fold like an 8.5 by 14 paper in half and then in half again so that you have quarters. And when it's folded into the fourths, the corner that's all the fold, you just fold up as a triangle. And then when they open it up, it creates the folds that look like this. And it's called diamond paper. And what this is called here is a multi-dimensional approach to learning. And it's allowing them to make the connections they need in the different representations and seeing it all in one space. And it's a really, really effective way to develop their algebraic reasoning and to bring understanding to each of these different representations, and to also have them recognize that all of these representations are talking about the exact same thing, the exact same relationship. So I'm going to ask you now on the Pear Deck to use green to show me in each one of the 4 corners where you see 3. Where do you see the multiplier 3 in each of those corners? So use the color green to highlight that. Then I want you to use the color orange to show me where you see the constant 1 in each of those 4 corners. I'm just going to point out for some of you who get frustrated when your students don't listen to instructions, some of you did not use the right color for this. I'm totally okay with that, but you know, every now and then we have to reflect on ourselves as learners and go, oh, hey. Excellent. So I can see most of you have grasped this. And again, feel free to come back to the Google Meet if you wanted to see some pictures of what some of your colleagues are saying. And is the scenario piece is really also important for them to get a context to what this might look like. So having students complete each of these 4 corners is a great exercise for them to start to make connections. And there is actually a new expectation we're going to talk about in a little bit that's called translate between different representations. And this is exactly what we're talking about there. So I can see that you've all found the 3 in all of the areas. Some of you are kind of like, I don't know where I would say the 1 is in the table of values. And you might want to start this without having a constant. When you first start this with students, you might want to start it with just 3n, so that they can see the multiplier in all the situations. But then you can have a conversation around term 1 in the table of values that 4 contains the number 1 as well. That 1 is part of 4. So you can see 1 in that 4. What you'll probably find is quite a few of them will circle term number 1. So that's a my favorite note. You can now bring that and highlight that in the class, that the term number 1 is not actually representing the constant 1. Where do we see the constant 1? Oh, it's part of term 1. And we can also see that in the visual representation. Okay. Another thing that you could do with this exercise is you could have groups of students working together. And I was going to do this with you, but I knew that we would run out of time if I did it. And I wanted to make sure we hit some other stuff. But you could give students a blank version of this multi-dimensional paper, or the diamond paper. And you could have them as a group, say a group of 3, come up with an expression, a linear expression, and then create the 4 corners for it, but don't put the expression in the middle. And then they can switch with another group. So the way I was going to do this was I had created a Google slide deck for you to use, that you were going to work in a group of 3 to create those 4 things, not put the expression in. And then you were going to use the slide that came after yours to, as a group, try and figure out what is the expression that that group came up with. So you're creating it, which is great learning, and then you're actually trying to use somebody else's diamond paper to figure out what their expression might be. So that might be a good way to play with this diamond paper and multidimensional approach. Okay, I want to revisit now this idea of equivalency. So we have these 2 expressions that we came up with based on the 2 different ways people saw this pattern growing. So we have 3 bracket n minus 1 bracket plus 4, and we have 3 n plus 1. And the conversation is, how do we give students an opportunity to explore whether those 2 expressions are equivalent or not? And our go-to, because of the way we were taught, is that we're going to have them simplify it. But this isn't part of our curriculum. It's not part of our curriculum to have them actually multiply through 3 bracket n minus 1 bracket. But there are other ways that we can do it. And it is important that students understand that expressions can look differently and represent the same thing. Because when they hit grade 10, they start to explore like a standard form, the y equals mx plus b form, the I'm drawing a blank on all the different vertex form. There's lots of different forms that they have to become familiar with and be able to use fluently for different reasons when working with functions. So it's great that at this stage in their math career, they have an opportunity to play with this. So one way that we can do this is actually by having them graph it. And if they graph these 2 expressions, I should get the exact same line. I wouldn't tell them that yet. So here's an opportunity, if you're on the Pear Deck, that Desmos is built right in. I want you to graph, and you actually have to include y equals when you're graphing it on Desmos. So I want you to graph these 2 different expressions here, and just put in the chat, are they the same or are they not the same?
So Rhonda, in that a box that's cell number 1, what are you writing? Sorry, I don't use this. I haven't used this program very much.
Yeah. So in that box that you see, you're going to write y equals like exactly what I have on the slide right there. Y equals 3 bracket n minus 1 bracket plus 4.
Okay.
And then if you click right under that, it'll open up another box, and then you can type y equals 3m plus 1. Thanks for asking that, Jamie. I was making assumptions there and I shouldn't have. So Chad Harris is showing some excitement with his exclamation marks here. This was a super exciting moment for Chad Harris to realize that they're exactly the same. I'm happy to bring joy to you today. Yeah, so what you should find is that those two lines will be exactly lined up with each other. And now there's that conversation again about what a linear relationship is, and that this proves that they're equivalent because they're covering the same line. Another way that we can demonstrate that, though, is using algebra tiles. If your students are familiar with algebra tiles, they should be from back when we did algebra way back at the beginning of term 1. So we can look at this, and this also helps bringing an understanding to this idea of what is 3 bracket n minus 1 bracket. So on the left side here, I've demonstrated that 3 bracket n minus 1 bracket is actually 3 groups of n minus 1. So I have 3 groups of n minus 1, and then I have these extra 4 positive tiles. And then on the right side, I have 3n plus 1 because I'm showing 3 n's, and then I have the 1. And from my work with integers, I remember this 0 pairs idea where this -1 and +1 are actually 0, so I don't have to think about those anymore. And now I can see that on the left side, I really have 3n plus 1, and on the right side, I really have 3n plus 1. And right there, I have developed their algebraic reasoning much more than if I had just shown them in a symbolic way how to simplify these two expressions. Okay, so that was the end of looking at visual patterns. So I just want to pause here for a second to see if anybody has any wonderings or questions before we move into what the curriculum's actually telling us to do. Was that enough wait time? Lene, I can see your face. Was that enough wait time? I never know how long is enough wait time. It's always so awkward. Silence and me are not friends. Those of you who know me well would know that. I see you laughing, Brad. Not funny. Okay, so our new curriculum has changed significantly in this topic area, and let's take a look at that. There it is. Okay, so what I have in front of you here is the grade 7 expectations for patterning and the grade 8 expectations for patterning. The words in pink are to compare between grade 7 and 8. So whenever you are focusing on them actually getting to the state of creating an algebraic expression or an algebraic equation, in grade 7, you are only ever doing that for linear growing patterns. And in grade 8, you are doing it for linear growing and shrinking patterns. The reason behind grade 7 not doing shrinking patterns is they have not yet been exposed to multiplying integers. And what we know about shrinking patterns is they're going to have a negative multiplier. And that's beyond the grade 7 curriculum. So grade 7, if you are wanting them to come up with an algebraic expression or equation, you are only doing that for linear growing. In grade 8, you can do that for both growing and shrinking. Some other new stuff, when you are looking at them, if you've given them an expression or you're giving them a pattern and you're not having them come up with the algebraic expression, in grade 7, you can be using whole numbers and decimal numbers. And in grade 8, you can involve rational numbers. And what rational numbers is positive and negative fractions, as well as whole numbers and decimal numbers. So that's a little bit new for us to get our head around. And then the pieces in blue are just bringing attention to the verbs. And something new for us in grade 7 and 8 is this idea of translating. So if you're looking at C1.2, we have create and translate. So what that translate means is that they are showing different representations of the same algebraic expression. And if you go into the curriculum, the example that they use there is if you had a repeating pattern of A, B, A, B, A, B, that you could translate that to clap, stomp, clap, stomp, clap, stomp. So I took it upon myself to contact the ministry and say, yeah, so we're talking in grade 7 and 8. I don't think we're going to do a clap, stomp, clap, stomp. So they clarified for me that what you would be looking at in grade 7 and 8 for translating these patterns is exactly what we just did. Translate them to a table of values, translate them to a graph, translate it to a visual pattern, translate it to a scenario, translate it to an algebraic expression. So that's what that translate piece means. So it's not like actually translating the pattern on a graph using transformations. That's not what it's talking about. The other new piece for 7 and 8 is this idea of repeating and shrinking patterns. We have only ever dealt with linear growing patterns in the past, and now we're also looking at repeating patterns and shrinking patterns. But a reminder, pay attention to the verbs, because in grade 7, they're only creating shrinking patterns or repeating patterns. They're not having to find an algebraic expression for it. So they could create a visual pattern for you that's shrinking. It could be a numerical pattern that they've created that's shrinking, but we're not looking at algebraic expressions. And then, of course, a repeating pattern would be like, I don't know, like a repeating pattern, 4, 5, 6, 4, 5, 6, 4, 5, 6, or a visual pattern that has like 3 parts to it that's the core component that just continues to repeat. And then was there anything else? I think that was all that I really wanted to address on those expectations. Really just go back and read them and pay attention to them. Oh, there is something in C1.1, C1.1, it's comparing linear growing patterns on the basis of their constant rates and initial values. And then the same for grade 8, you're doing that on the growing and shrinking on the basis of the constant rates and initial values. So there are some great lessons in this book, From Patterns to Algebra, that was given out to all math leads, I think, in the second year of the math lead program. So there should be a copy of it in your book. If there isn't, or in your school, if there isn't, beg your administrator to buy a copy for your school. There was one originally given to all schools, but sometimes books grow legs and disappear. There's some great lessons in there about looking at the difference when we're looking at a graph, like what happens, how much quicker does it go up if we have a different slope, how much slower does it go up, how does that constant connect with where the pattern is starting. Just a reminder, we don't need to go into slope and we don't need to go into y-intercept. Those are terms that we don't have to go into in grade 7 and 8. If you're feeling your students would be confused by that, you can just keep it at multiplier and constant. Okay, that was all I was going to say about that, except we've never taught shrinking patterns before in grade 7 and 8. So one way that we can approach this, and this comes straight from that book that I just shared with you, From Patterns to Algebra, is we could, lesson 22, it's the very last lesson. If I was doing this with my grade 8 class, this would be the last type of pattern I would be asking them to do an algebraic expression for. Grade 7s, you don't have to go this far with shrinking patterns. They just need to create them. But this is coming straight out of that book. It's beautifully outlined in there, so we don't have to spend time on it. But it starts, this is the mind on what rule does the graph represent. So you want to give this to them after they've had lots of opportunity to play with the different representations on linear growing. And then you could have them ask what story might the graph represent. So putting it to some sort of a contextual situation that helps them make sense of this negative idea. And then again, providing them with diamond paper and giving them this expression and having them come up with like all of the different representations that this expression could bring. And I've actually created a slide deck right there that you could just steal and use, that you have access to. I'm just doing a time check. I think we're doing well. So just to recap, this is the trick that we are going to nix. We are not approaching teaching patterning in this way anymore in grade 7 and 8. We want grade 9 to be able to build off of the work that we've done, and this is directly out of grade 9 curriculum. So not our job to do it. We don't have to worry about it. We just have to develop their algebraic sense so that when they get to this point, this M and this B makes better sense to them, and this idea of slope. Okay, so moving into what resources have we created for you to help you with this topic. We have, and there's links on this slide. These are also embedded in the long range plans on the patterning topic page. There is a diagnostic for both grade 7 and grade 8. It's a slide deck that's already been created for you. You just have to go through and use it. There are look-fors that are on that slide deck for you as a teacher so you know what you are actually assessing. And then there's a developmental tracking sheet. When you open that, it's going to ask you to make a copy. And then these tracking sheets have all 4 non-negotiables on them. So you'll have to go to the bottom and click the tab that says patterning. But those tracking sheets should be super helpful for you to help determine the benchmarks of your students and what the next steps for each student is. We also have, this comes out of our Leaps and Bounds resource, which, by the way, every grade 7 and 8 school also has a copy of the teacher resource and the student Blackline Master book. And this goes in, this is going to be a reference slide. I'm not going to go through them with you now, but these are some possible reasons why students might struggle with patterns. It's worth you taking the time to read those over so that they're already on your radar and you can maybe identify what are the blocking points for students. And that's 2 slides. So there's 2 slides about that stuff. And then Michelle Lang has created for you a sample week at a glance. So this can get you moving in the right direction on the patterning topic. And that would be week 1. And then based on what you see in week 1, we'll determine what week 2 and what week 3 will look like. So that's it. Today, holy, did I ever do well. Today, these are some of the strategies that we use to help students understand what we're talking about. We used visual patterns and color to provide flexibility and conceptual understanding. Always using visual cues, as we know it helps our students that have executive functioning concerns. We didn't actually end up going to this because it's too hard in 1 hour to be able to do everything I want to do with you people, but Google Slides as a vertical non-permanent surface is great. That graphic organizer for multi-dimensional learning. Oh, we didn't go into collaboration either. I had group roles, so if you click on that, I'll take you to a slide for group roles. We didn't do random groupings, but we did use Desmos, algebra tiles, and Pear Deck. So some of those are lies, but most of them are true. And the next time we are getting together, it will be for measurement, and that will be on April 6th from 4 o'clock to 5 o'clock, and it's always at the same Google Meet link. And just a reminder, everybody is starting this topic on March 15th. So we do have a good 11 minutes. That's got to be a record for me. 11 minutes. If anybody had any questions that they wanted to take this opportunity. Otherwise, I thank you very much for coming, and hopefully we see you on April 6th. Doesn't new curriculum have multiplying integers in grade 7? No, Brad, it's in grade 8. But it does have multiplying fractions in grade 7. That might be what you're thinking about, which has changed. So multiplying a fraction by a fraction is in grade 7.
Oh yeah. Oh boy. Thanks.
Yeah, we're all getting our heads around it. Every time I go to talk about it, I have to go back and study it. So no worries.
Oh. Rhonda, is it, sorry, I know it's not math, but are you working, who's working on the science? I was away, I'm having trouble finding some of the things, and I wasn't sure if there's more information for grade 7 science for distance learning. Is there much floating around on that, or we're pretty much just using? There were some things were put out right at the beginning, some really broad things from like Dawn had some